You're going to go to student.desmos and you're going to join this session. And when you get there, the first 4 slides are pasted. They're accessible to you all. So please complete those first 4 slides. I'll leave this code here, RSENJ5. It look like I'm waiting on 2 more. So yeah. All right, so in the interest of time, I'm going to pause the activity here. 3, 2, 1, pause. And I'm going to take a look at this dashboard. So I'm going to ask you all to just look at my shared screen here. You can see we mostly got checks. Somebody, a really good guesser, the number was 6, as you were told. I put myself in here so that I would produce a check mark. And then we got dots here. And that's really what I want to focus on today is like, how do we turn dots into checks? And I was curious what people even think that dots and checks mean. So here were some of the answers that I saw from this group. Everybody kind of knows check means that we have correct answers. It was self-checking incorrect. I think that's kind of what we're getting to. We'll talk a little bit more about what it means to be self-checking on the teacher dashboard side. And then the dots, an incomplete answer. There is something the teacher needs to check and there is not a correct answer or the teacher needs to look at it. And so these are all partially true. Dots are when students are still working, there's a dot. So a student is still there. There's something a teacher needs to check. That's a really big piece. So I went and wrote, this is how I think of it. Not to say that this is exactly right, but this is the idea. Everything on the screen can be evaluated by Desmos, or Desmos has been told to ignore items. That's what produces a check mark, and everything is right. A dot indicates nothing is incorrect, and that's really key. Nothing's incorrect, which is why you get dots on multiple choice questions sometimes, because they got the right answer, but there's something else getting in the way that Desmos doesn't know to ignore. It's usually a graph or a sketch. But the other big reason we have a dot is we need human interpretation. Like there are some things that computers shouldn't do, and we need to read. That's where we're really checking for understanding, not checking for correct answers. And that's what we do as educators all the time. And then a dot will always follow a student wherever they are on the slide. So just to kind of clarify, that's what we have going on there. Now, what I'm going to end up doing today is hoping that we finish with these 3 things, that you can identify screens that display check marks without CL. CL is the computation layer. I assume that's why you're in my session, because you have a little bit of comfort with actually putting in some commands into the back end of activities. Identify screens that can display check marks with the help from CL. And then we're going to actually put some computation layer to work. I'm going to have you all practice. So I'm going to show you some things and then give you some challenges and stick on the call, and you can work on them now or return to them and get in touch with me during the week. Sounds okay? Cool. I'm going to pace you all to the next 3 slides. I just want to get a sense of, do you know when a check or a dot will show up? So on slides 5, 6, 7, just do a gut check. Don't worry about if you're right or wrong, but on the left-hand side is an image of what a student would see and their answer. Do you think that will produce a dot or a check mark? That's all we're going for here. So take a moment and work through 5, 6, 7. Please. Perfect. That is what I was really hoping for. All right, I'm going to give a pause. I think you read the feedback along the way of why certain things happen the way they do, but I just wanted to share, this is what makes me excited, right? Most of us were able to discern that on a simple multiple choice check without utilizing computation layer, Desmos can evaluate that, right? This is like what a Scantron does. So Desmos is just a more powerful Scantron. If you tell it the answer key, it will mark it right or wrong. And on a multiple choice purely, we can do that no problem. And I'll clarify how to do that. Most of us figured out, actually all of us figured out this is a dot. Because it has that explain your thinking, we need that human interpretation. And then this is the one that I love seeing what happened. The correct answer is a dot. Why is this a dot? So for that, I'm going to share my screen here with the next one. So remember, it was just a multiple choice and a graph. And I'm going to walk through, instead of having you look at this, I'm going to give you access to read it on your own after. This is how I think about Desmos. So there are 3 types of components that happen on a screen. There are thought-provoking components. Those are notes, media, and buttons. This image is meant to do something for you. Sometimes instead of an image, we use a graph. And a graph can kind of be both, because sometimes we want students to graph, and sometimes we want the graph to display information, like in this question here. And when that's the case, Desmos doesn't know to ignore this, because a student could interact with it. We have to tell Desmos to ignore it. Thought-seeking components are text inputs, math inputs, multiple choice. That's where we want a response from a student. Those are almost always going to be ones that can be checked, except for text input, without any help from CL. We can just give it an answer key. But when it's one of these 3 in particular, we need to code. So just kind of as a recap, nothing CL can do. Anytime you have information only, or screens that use text inputs, we're not going to be able to produce a check mark. We don't need CL for multiple choice checkboxes, ordered lists, and card sorts. We can enhance those with computation layer, but we don't need to use it. And then it's sometimes we need to tell Desmos to ignore an element, and sometimes we need to highlight it. And so this is how we do that. Ignoring components are going to use a command called read only. It looks like this. When you want Desmos to ignore something, you write read only true. In that multiple choice with a graph, the graph is getting in the way of the computer being able to produce a check mark. So we would just go to the computation layer for the graph component, write read only true. This is your biggest friend, and we'll see that in a second. When you want to add correctness, you're going to use the command correct with a colon, and then the condition that makes it correct. So this is just a placeholder. That's not really the code. That's like, what do we want to be correct, right? Sometimes the answer is 5. Sometimes the answer is 17. Sometimes it's an expression like 2x plus 5. So we're going to look at that and figure out how can we mark things that are correct. OK? Read only, correct. That's what we're going to focus on today. So let me take you through a little journey here. And I know you're still paused on the student side. We're going to ignore the student side for right now. That's going to now be how you have access. So everything will just be on my team screen with the share. So let's take a look. This was that question that we were split 5 and 5. And it's got multiple choice and a graph. On the back end, before I hop into actually live building with you all, this is what it looks like on the teacher author side, right? Is everybody familiar with that? You just give me like a thumbs up. You've seen the backside of Desmos. Okay, so if you haven't seen the teacher.desmos.
Still don't have a chat, so I can't do anything, but I have my hand raised.
Okay.
All right. I haven't created really. I just use what's already made.
Okay.
I don't like recreating the wheel.
Oh, I hear you.
So is there a way to edit things that are already made?
Yes. So that's what we're getting to today, and that's where I'll have you practice. And so what I'm going to do is hop into an actual activity. On the backside, it looks like this. You can see it kind of looks like this screen. It's just a little clunkier because we have more options to do on the backside. So what I really want to draw your attention to is this green circle is how you access computation layer. And that's where you're going to, like on this screen, to produce a check mark, all we need to do is add one little piece of CL and we'll smooth up the screen. So I'm going to hop out and I'm going to show 4 examples right here. So this is the teacher created side. And I'm going to add the computation layer and ask questions, please, if you have them, as we get going here. So for this first one, I'll give you a student preview. What is the y-intercept of the graph shown? Well, we all know that the y-intercept is right here at 0, 3. But I'm producing a dot. Everybody sees this, yes? All we need to do here to produce a check mark, click on that little circle, and then read only. When I start typing read only, computation layer wants to help me. It says you're probably looking for read only. I hit enter. I want to make that true. Read only true. That warning symbol went away when I hit done and preview and select 0, 3. Now I've got a check mark. It's as simple as that. Any questions there?
How do we get to that?
So you're not going to have it yet. I'm going to give you access to this in a little bit. But this would be from any activity that you had on the teacher.desmos.com side. And I will show you that in a little bit. But for right now, I just want to work on the actual coding itself. And then I'll send you this activity to modify and answer these challenges. Is that cool, Lee?
Sure.
All right. Another interaction. So let's talk about this one and you all let me know. Table with missing cell values. Can somebody just tell me what's supposed to go here based on what you see? What are we looking for?
6.
So you think a 6. So if I'm going here, I'm going up by 1s, up by 2. So you think a 6 will go there. It's going to produce 7. A dot. A 7. April, talk to me. Why'd you say 7?
3, 5, 7, 9. It's like a pattern.
Okay. So this pattern seems to fit a little bit better here. Yeah. I am looking for 7, fitting that pattern, going up by 2s. All right. But I still produced a dot, right? Why am I producing a dot? Well, in this case, it's not that I want to go read only. It's that I need to tell Desmos how I want this to be correct. So now I'm going to do that correct and condition idea. So I type correct, I hit enter, and the condition was when the student writes 7, right? So what I want to think about is something needs to equal 7. Now, Desmos has a little like tricky way of thinking about it. So What I want is that specific cell to be 7. And this is where this little question mark takes you to a documentation that tells you how to write things. But I'm going to just share with you today the way that Desmos likes this notation is the rows and then columns is how we define it. So this is row 1, row 2, row 3, and column 2. So I need to tell it that when the value of row 3, column 2, is 7, then this is going to be correct. So I'm going to hop back in and I'm going to go here and I'm going to say when the cell, I'll type this dot cell numeric value of row 3, column 2. That's what this says. So I'm using this for the component because I'm inside of this component. I can call it this. I don't need to name it. So within this component, the dot just means more information is coming. I need the numeric value of row 3, column 2 to equal 7. When I do that and hit preview, 7 produces a check mark.
I have a question.
6 will produce an X. Yes.
Can you make it something other than a numeric value, or does it have to be a numeric value in a table?
You can make it something other than a numeric value, which we're going to look at next.
Okay.
Which is a great question. But I'll let you know that numeric value, right? Notice I can type 4 plus 3. I still get a check mark. So there, sometimes you want this, sometimes you do not want that, right? But I wanted to go with just a numeric value because I figure like maybe I did want a student to recognize that this this pattern is twice my number plus 3, right? Which is what we're getting to next. So here, another common question that we ask, right? I've got a table and I need an input. So right now I can see, I know because I made it, this is negative 2x plus 9, right? But not every student likes to write slope and then y-intercept. In fact, when you're first learning this concept, you might be like, this is 9 minus 2x. So like, I want super flexibility here for my correctness check. And I'm going to show you all how we can be simplistic and how we can get a little bit more sophisticated to accept both of these answers as correct. So this, I think, answers your question, April, about when we have an expression, what can we do? So 2 things here. Remember, Desmos doesn't know that this table is informational. It could have been student input. So we need to tell Desmos, ignore the table, and we need to add correctness into the math input. So we've got 2 tasks here. So I'm going to start. Does anybody remember, how would we tell Desmos to ignore a component?
Read only true.
You got it. So you're an expert already. Ignore things, read only true. That's helpful. But I still need to tell it to be correct on this input, right? And this is where we're going to get a little bit sophisticated. Correct. What's my condition? So did we remember the expression? I started writing really quickly. I'm going to tell you all the expression. Negative 2x plus 9, yeah? I'm going to show you several ways that we can do this and explain it. So this, again, I'm within this component. So I'm just trying to tell Desmos when students are typing here, I use the word this. This, LaTeX is math type. So it's accepting whatever the student types in. So whatever the student types in, I hope it equals. When I use quotes, this is a little bit dangerous because I need students to type exactly this. All the spaces matched perfectly. So I'm going to show you that this works, and I'm going to show you that it doesn't work and show you a slightly better way. So at the most basic, I can write equals quote negative 2x plus 9. When I hit preview and I type negative 2x plus 9, I'm producing a beautiful check mark. But if a student happened to hit negative 2x space plus space 9, I get an X. How many students do that all the time, right? So we don't like this. So here's a way to tighten it up. Instead of quote marks, you're going to use backticks. Backticks turn the text orange. It's the key right above the tab button. So it has that tilde on it. That's a backtick. This is now interpreting it as math text. And the reason that's really helpful is that if a student writes spaces, it will not affect the answer. So negative 2x space plus space 9. In fact, I can have as many spaces as I want. This will not affect the fact that negative 2x plus 9 is correct. So that's like a little bit safer of a way to check for correctness. Does that make sense? Okay. At its most basic, that's what we can do. but what about 9 minus 2x? This is equally correct, right? But now I'm producing an x. So if this is the level of coding you're comfortable with, and you want to check x's to be like, maybe students wrote it the other way, you know, that b plus mx format, that's okay. I'll spend my time going through x's, but we can teach Desmos to be a little bit more flexible, which I would like to show you right now, just so that you see it. So I'm going to gray out this, put a hash tag in front of code. It tells it to ignore the rest of the line. And I'm going to write a new statement. For the sake of time, I'm going to copy paste it from something I already have written. And I'll share this. So let me walk through what it says. Correct under this condition. This whole condition is true. This is the important part. I'm going to tell Desmos, whatever the student types, so this student types, make it a function and evaluate it at 7. So I'm just going to tell Desmos, drop a 7 in for x here. I'm hoping that that matches the expression that I actually want students to do is negative 2x plus 9, evaluated at the same number, at 7, right? These should be equivalent expressions. So if I do this, and I drop into my preview, negative 2x plus 9 still works, but 9 minus 2x will now also work. So just that one little extra twist really kind of takes it to the next level where you're protecting yourself against lots of student thinking, and you can celebrate a lot of successes on your dashboard, right? Because now you can highlight different ways that students are getting this correct. I'll leave that there for just a second. And I will proactively mention one other bit of text of code that we can do. Like, what happened though if a student just wrote something that would also evaluate to be -5, right? Like if a student wrote -5, I believe they'd still get a check mark here because -5 has nothing to evaluate against 7, but negative 2x plus 9 would be -5, right? Does that make sense? So like we've kind of coded it incorrectly, like we haven't protected ourselves against everything. The way to fix that would be to give it more things to evaluate against. So I could say like, hey, I need you to evaluate at 7 to also be my expression at 7. And I want you to also evaluate at 17 to equal my expression at 17. And if you really want to protect yourself, give it a third condition and evaluate at -7 to the same thing as what I'm doing at -7. So again, it's just multiple checks, right? Just in case a student happened to guess a system of equation that was correct at 7. That's what I'm looking for there. These are just more robust checks. Does that make sense? And it will only mark this correct if it makes this and that true. So I need all 3 statements to be true. I'm going to take a beat right there. Questions? We're doing all right. Okay.
I have a question.
Yes, please ask.
The commands that you use, are you getting those from a list or you have to know those?
So there is a list that you can get them from. It takes a while to load the website, so in the interest of not doing that for you all, but I'll show you how to do it. When you're inside of this computation layer, if you don't know how to do it, if you start typing something, it starts telling you what you can do. So when I write this, all of these are showing up. So like it's trying to tell me suggestions. You're almost always going to use these top 2 after you write this, LaTeX or numeric value, just to start. But if you want, when you click this question mark, it'll open a new tab. And then Desmos has a computation layer documentation that goes through in detail what everything is doing with a sandbox included. So it has examples that you can hit, try it, and look at their code, copy, paste, and modify it. But for most of the checks that you all would be doing, when you do correct this, that's going to trigger a LaTeX or numeric value for right now.
Hey, Javier, I have a question.
Yeah.
Now, going back to the table question, does that only work for one value of a cell? What if you have like, say if you're trying to get the kids to input like 3 or 4 values into a table, can it still do that check or is that impossible because there's multiple things going on?
No, you can check the whole thing. You would just have like, instead of, you're talking about on this table, like if you had them do everything, like the 5 and the 7.
Yeah.
I mean, this would be impossible to know, right? Like students don't have enough information, but you would just do it's correct when it's this and this dot cell numeric value, but this time you wanted row 2, column 2 to equal 5.
Gotcha.
then so now you're just telling it you need this to be 7 and you need this to be 5, right? Row 2, column 2 in this case, row 3, column 2 in that case.
Okay, cool. Thank you.
Yeah, and you wouldn't do new correct statements. Everything is just going to be what is correct, and then you can have all of your conditions that make it correct.
Okay. Do you ever do a lot of self-checking with that, like with this feature as well, or not typically? Two different things.
It's two different things. So we can talk more about making things self-checking on the student side, but all of this is just to clean up to make the dashboard work for you as a teacher. And so none of this is student facing. They won't see that they have check marks, but this is what this session is about, making your world more efficient on the back end, whether you're recording grades or to have conversations in class. Yep.
Thank you.
No worries. Great question. Okay, last example I have, and then I'm put together some challenges that are similar to these for you all to practice building, because I know that watching me do it is not as helpful as you yourself doing it. So the last screen here, we often have this type of question, right? And we give students an opportunity to sketch. So again, thinking through that lens of what do we care about? We care about this answer, and this sketch is very useful to us as teachers, but not to Desmos as a grading tool or an evaluating tool. So we need to ignore this sketch, and we need to assign correctness here. Okay. So when I go to the coding side, although this sketch is going to be useful to me as a teacher, I want to mark it as read-only true because it's getting in the way of producing that beautiful check mark for me. Then the next thing I need to figure out is, well, what does this evaluate to? Well, 3 times 7 is 21, 2 times 3 is 6, so we're hoping for a 15 here. And at its most basic, we're just going to accept 15. So what do I want to be 15? I want the student's, numeric value. I'm so sorry. To equal, was it 15? This would handle it. For the majority of the cases, that's all we want, is to produce a check mark when a student writes 15. Again, could they write 3 times 7 minus 3 times 2 and get a check mark? Absolutely. But that's where the numeric value, in my opinion, for this would be a skill that I want to know which of my students just know to substitute and which of my students know how to compute. And I'm going to show you one extra little piece here that's not correctness, but some teachers don't want their students to do this and not go through simplifying. So one thing we can do is disable this evaluation. So I don't want students to see that this equals 15. And that's one extra little piece of code that has nothing to do with correctness, but lets you do that. So I'm going to write a D for disable evaluation, and I'm going to write true. Now when a student goes and they write 3 times 7 minus 3 times 2, they're still going to get a check on my dashboard. That's really useful to me as a teacher. I know that a kid knows what they're doing, but I also know that this student now probably needs a little bit of help with actually going through and simplifying. But this is really great for me to know that that's the comfort level of this student. They're ready to substitute variables, and they're substituting appropriately. They just aren't comfortable yet with order of operations. Probably not a really realistic case after like a day of doing things, but you get the idea. You can always disable those cells if you add disable evaluation true. It has nothing to do with correctness and everything to do with what you want students to do. Any questions there? Okay, I'm going to paste you all to slide 14 for a second. Just kidding, 15. So if you go back to the student.desmos.com activity that you all were in, I see 5 of you have gotten back there. If you'd left it and you go back to that screen, that link is where you can test your CL skills. Okay, I am going to ask you to, and I will modify the pacing, to go back to screen 14 at some point because I just had a quick question about our lesson goals and a survey for the end of this. But because I know a lot of you have block 1 coming up, I want to just get you to building and let you know that when you go to that link to test your CL skills, you're going to hit copy and edit. So for anybody who does not know, when you land there, you should see this. 3 dots in the top right corner, copy and edit. You'll get copy of, turn dots into check marks. And this is where you can add in the computation layer. So I try to rank them as beginner challenges and then get a little bit harder as you go. I will let you all know that this third intermediate, I was debating between making intermediate and advanced because at its most basic, you can produce a correct check mark. But if you want to protect it with a simple function, that's a very sophisticated move when there are two variables. So if you want to try that, reach out to me, send me a message. I'm happy to help with that. But at its most basic, we know this can equal a numeric value. But if you want a more sophisticated check, that's going to take a little bit more coding work there. But at this point, I just want to invite you to ask questions, play, or give yourself permission to take a beat before the class load starts today. And that's all I have for you.